So this long number at the top really represents 2,480,631. But the process to convert from binary to decimal is what we just did, and it's a little bit tedious. This is a really large number, and it's pretty difficult to write in all ones and zeros and easy to make mistakes. The 2,480,631 is a nice number that we know very well, but it's difficult to translate between the two. It would be nice if we had a shorter numbering system that we could easily expand out to all ones and zeros, but was also easier to read, like 2,480,631 number. Let's consider a new way to represent numbers that has both the advantage of being easily translated to binary, but also easier for us to read and write. The reason it's so difficult to translate between decimal and binary numbers is because when the decimal system, 9 to 10, changes columns, is at a different place than when the binary system, 15 to 16, adds a new column. Let's look at a new numbering system that adds new columns at the same time. When we get to 9, we've run out of symbols for numbers in one column. 10 is normally represented by 2 columns. So what do? Well, we can borrow from the alphabet. Let's call 10 A, because that still fits on one column. 11 B, 12 C, 13 D, 14 E, and 15 F. And then we can start over and say 1, 0. This numbering system is based on 16 because there's 16 different symbols that we can represent in one column. It also has the added benefit of adding to columns or changing columns at the same time the binary system does. This numbering system is called base 16 or hexadecimal. Because this numbering system changes numbers at the same time as the binary system, we can break this big number, this 2,480,631 number, up into chunks and represent it in hexadecimal. The first chunk, 0111, is a 7. The next chunk, 4 ones, is an F. Third is a 9, D, 5, and 2. So we can represent this really long binary number in a much shorter and much easier to read numbering system called hexadecimal. That's where you see on your Windows calculator this 25D9F7 is equal to 2,480,631. Because hexadecimal adds a new column at the same place that binary system adds a new column, we can break this large binary number up into chunks and represent each chunk with a hexadecimal number. This way it's very easily converted between the two. This first chunk is a 7, as you can see in the table, an F, 9, D, 5, 2. This 25D9F7 is also equal to 2,480,631. If you don't believe me, go add up 7 plus 16 times 15 plus 256 times 9 plus 4,096 times 13 plus 5 times 65,536 plus 2 times 1,048,576. You will arrive at 2,480,631. This 25D9F7 equals 2,480,631 in hexadecimal. This can also be shown in your Windows calculator under program mode. When you type in 2,480,631, you'll see that big long binary number at the bottom, but you'll also see 25D9F7 at the top. Again, these numbers are very easily related because they can be grouped together, unlike decimal, which you actually have to do the addition to convert between. But hexadecimal has the added benefit of being much shorter and much easier to read than a long stream of ones and zeros. You will often see numbers represented in hexadecimal form when you're working with computers. It's important to understand what it is and how to convert between it and binary.